All right, so I want to move on to doing a little bit more with expressions, right? So patterns. Right, so you can actually notice patterns in real life and you can make equations out of it, right? So a really simple one, like say you see this pattern. Right, what are the things that you see that are constant, right? So our constants, things that are constant would be we're always adding 2, right? In every single problem we're adding 2. And we're also multiplying, there's also 3 times something, right? We're multiplying 3 by a number. What's changing? What is varying? That's why it's called a variable, right? Because it can change. It's unknown, it changes. So what's our variable? That would be the second number here, right? This number is the only thing in this pattern that's changing. So our variable would be, we can call it x. It's the number multiplied by 3, right? So we can make a pattern from this. 3x plus 2. So we have our constants, right? And we have our variable, the number that changes. And then I've created an expression to represent it. So if you do any kind of like baking, that's a recipe is essentially just like a really basic pattern. So if you want to double your recipe, right, you would double the amount of everything in the amount. You're multiplying everything by 2, right? If you want to triple it, whatever. So depending on how many people you want to make, you know, cookies for or cakes for or whatever, that varies how many people you want to serve. But what stays the same, what's constant, is the base measurements for your recipe, right? So if you're going to serve 10 people, maybe the recipe calls for 2 eggs, 3 cups of flour, whatever, you know, but what might vary is how many people you want to serve. Okay, so there's patterns there. Same thing with like if you wanted to become a nurse, they have formula charts for drugs, right? Because you don't want to overdose somebody and kill them. You don't want to give somebody too little pain medication and then, you know, they're in pain the whole time. But then also people are individuals, right? So you might give them the proper dose and they're like, I can still feel the pain. Then you just have to know what's my limit, what's the upper limit before they start getting negative side effects, right? But these are all based off of formulas. So they might have a dosage based on somebody's height and based on somebody's weight that should work for them. And then, so that's your changes, right? So if you think of like a nurse dosage formula and they have so many different formulas for different drugs because you have to take into account different kinds of side effects and things like that, right? And all drugs have different dosing information, right? But what's gonna maybe stay the same is like the amount of the drug per pound on a person. That's really simple. Usually there's a lot more factors and their formulas are a lot more complicated, but we'll make it simple, right? So the dosage stays the same. And if you read like if you have like Tylenol or whatever, it'll tell you age recommendations. So sometimes it's age, sometimes it's weight. It really depends, right? So that stays the same, right? But what might change would be the weight. The weight of the patient, right? So this is the variable, right? And so the nurse would take all of this information on the patient, they'll plug it into their formula chart so that they can apply the proper dose of whatever drug they need to give to their patient when they're in the hospital, right? Or even just you get a prescription, things like that, right? So all of this, that's all algebra, right? Really important. It's all about recognizing patterns. We find dosage patterns, things like that, and then putting in the appropriate variables based on your patient because they're all individual and, so you can take care of them properly. Okay, so again, you know, using patterns in real life and applying algebra in real life. Okay, and then last thing I kind of want to talk about is a substitution table. And it's essentially what we were doing before with substitution, except it's in a table form. So you might see something like this. It's used used a lot, where there's X represents I don't know what. This side of the table is all the different values of X, and then this is what happens when you plug in X into the expression. So this makes more sense when we do an example. So let's say we are using the variable X, and our expression is 2x minus 3. Okay, so I want to evaluate what is the value of 2x minus 3 if x equals 0, or maybe if x equals 1, if x equals 2, if x equals 3, so on and so forth, right? So I'm just going to substitute this into my expression, and then I evaluate it. So 2 times 0 is just 0. 0 minus 3 is just negative 3. And this time I'm going to plug it in with 1 instead. 2 times 1 is 2. Here I can rewrite it in steps. 2 minus 3 is negative 1. This time I'm plugging 2 into x. 2 times 2 is 4. 4 minus 3 is 1. Then we do 2 times 3 minus 3. 2 times 3 is 6 minus 3. 6 minus 6 is 3. So that's the same thing that we were doing all the way up here with these if ones. It's just written in a table form. It's just a different way of looking at it. Right, so I'm saying if x equals 0, what is 2x minus 3? If x equals 1, what is 2x minus 3? If x equals 2, so on and so forth, right? And then we get different answers. Right, so again, patterns, that's what these are, these expressions. X is the variable, it changes. So this is why there's no one right answer for 2x minus 3. There are lots of, these are all right answers because they depend on our variable, on what the value of our variable is. All right, so that's a substitution table. Hopefully it's straightforward. You know, sometimes it's even empty, so you might have like a substitution table and it says fill it in. Let's see, negative. So something like this. If it's empty and it says fill in the table, that means you can pick any number for x. So let's just say I always like to make them small because it's like simpler numbers, you know, but you can pick any numbers you want. I don't know, you could even do like 500 for, you know, whatever you want. They'll usually have like slots for you, so you know how many to do. And so yeah, you can pick any value for x, and you just plug it in and substitute. Right, so 3 times 0 is 0. 0 plus 2 is 2. Okay, so that's the first one. Negative 3 times negative 1 is going to be positive 3, right? Plus 2, we get 5. Negative 3 times negative 5 is positive 15. Plus 2, so we get 17. I also would recommend like circling, squaring, whatever, making your answers really, sorry, that was the laundry. Making the answers really clear, that's if you're doing handwritten, just so I can easily find your answers. Okay, and then negative 3 times 500, right, so that would be negative 1500 plus 2 equals negative 1498. I think I did that right in my head. So hopefully that's straightforward. It's just what we did before, substitution, just in a table form, and you can pick your x values, right? Yeah.